Example 3 for writing slope-intercept form equations. The first thing that we notice here is the points are not lattice points. We get some mixed numbers in here, we get fractions in here. It's going to make our job a little bit more difficult. With regard to finding delta y over delta x, we can't necessarily look at the values like we did with the previous examples. I'm going to pull one of those up here real quick. See, for the most part, when we look at how do you go from 2 to 11, it's very easy to go, oh, you add 9. How do you go from 5 to 10? Oh, you add 5. It's pretty simple to do that. With the mixed numbers in here and the fractions, it's not necessarily as easy to do. And so we want to go back and review what it means to have slope. Slope is m, which is delta y over delta x. Here's my deltas. It's also defined as y2 minus y1 over x2 minus x1. Now notice, if you're looking at this, if these are x values and then y values, the y2 and the x2, that's actually what's written down here, so it's going to reverse that order. You would go y2 minus y1 to figure out that change in value. If I'm going to plug that into a calculator, and that is my intention, I'm going to turn my calculator on here. I am using a graphing calculator, but it's going to be the same concept with your scientific calculator. I would type in 1 and 1/2, and then I need to go minus 2/3. Now that gives me 5/6, and so I'll write 5/6 here for my delta y. In a similar way, when I look at the x values, I need to type in 3 and 1/4 minus 5 and 1/2. Now that gives me negative 9/4. Now as we try to write our slope, we know that slope is delta y over delta x. Slope is always written as a fraction. So when I write 5/6 over negative 9/4, that doesn't work out for me because that's not a fraction. It's not something that I can easily recognize. I can't tell you whether it's steep, shallow, or standard. And so I'm going to have to put that into my calculator and reduce it. Now, because I understand the basic principles of math, I'm going to type this in as 5/6 times, yes, I did say times, the reciprocal here, which would be 4/9. And that gives me 10/27. And it would be negative because of the negative on the bottom. So I get a slope of 10/27 negative. Now you may look at that and be a little flustered. That's part of learning math. I'm allowing you to use the calculator, so I expect you to use the calculator and follow the procedure. So once I have a slope, I can say y equals delta y, delta x, x plus c. I can plug this in. I'm half done. Negative 10/27 x plus c. I have a slope. I just have to find an intercept. The intercept may not be a very nice value, but that's life. We're going to look at one of these points, decide which set we want to plug in here. I think I'm going to go with the second set. You can't choose wrong, just choose a set. I'm going to put 3 and 1/4 in for x, 1 and 1/2 in for y. So I go 1 and 1/2 for my y, negative 10/27 times the x value, which is 3 and 1/4, plus c. Now, if we're going to use the calculator, we might as well use it in its full capability. There's no sense figuring this all out and then moving it over. We can take this as one big term, move it over, do all of our calculations in one step. And so I could write this as 1 and 1/2. Notice that this, as a big term, is negative. So I can pull it over and say plus 10/27. You'll never change this x value. Even if this was negative in here, you just leave it alone. You only change whatever the slope is when you move it, is what I'm trying to tell you. So when this slope is negative, it comes over as a positive. I'll leave the x value as whatever it was, in this case 3 and 1/4, and that would equal c. And now I have to figure out what c is by using my calculator. And I'm just going to plug this all right in here. You can do the same on your scientific calculator. I'm going to go 1 and 1/2 plus 10/27 times 3 1/4. And that gives me 73/27. Now, with 73/27, I don't want to put that in there because I need to immediately know where the y-intercept is. And so what I'm going to do is convert that into a mixed number. I want to know that it's about 2 and 19/27, so it's somewhere around 2.5, a little over 2.5. And so when I write my equation, I take all this information. I have a slope, I have an intercept, and I'll write this as y equals negative 10/27 x plus 2 and 19/27. As I describe this, I can say because of the slope being negative 10/27, that's a proper fraction. That would be a shallow decline because it's negative, and the y-intercept would be located at 0, 2, and 19/27. I did switch colors of pen here for a reason. I want to come up here with the first two examples. It didn't matter, but a slope is always a fraction. In our class, slope is always a fraction. The y-intercept, well, that could be a couple different things. Y-intercept is either going to be a nice value, it's going to be a whole number. It could possibly be a proper fraction. It'll never be improper. If it's improper, I want it listed as a mixed number because I want you to be able to immediately figure roughly where that's at. So 2 and 19/27, we know it's somewhere above 2 but less than 3. I want your line to illustrate that you see it going through there as we get into the graphing phase, and that's obviously where we're going to go next. Right now we're writing the equation. Next phase, we'll graph them. Hopefully we don't have numbers like this to graph, but if we do, I mean, you know, when you do stats, it's never a guarantee that you're going to get nice values. You have to be able to approximate where that's going to cross your y-axis, what it's going to look like, and that's what this is all about. So there was example 3 where we had some fractions, we were using our calculator. You need to be able to use that calculator effectively.